Namaskar, welcome to Exercise Explained. In this video, I would be doing question number 10, 11th and 12th of exercise 2C, that is motion in one dimension, ICSE 9th. I would be completely solving these three problems. The previous problems have been done in the previous videos, the link for which will be provided in the description below. Do check them out if you have not seen them by now. So without any further delay, let's start with it. When brakes are applied to a bus, the retardation produced is 25 centimeter per second square. Now as I can see here, the retardation is not given in SI unit. So I definitely need to convert it to SI unit. And the bus takes 20 seconds to stop. So time is given as 20 seconds. To stop means final velocity is 0. Calculate initial velocity of the bus. So we need to find the value of u. Distance traveled by the bus during this time. So we need to find s. Now the first things first, I need to convert this to centimeter per second square to meter per second square. Now acceleration, I have written it as minus 25 centimeter per second square since it is given in the question as retardation is 25 centimeter per second square. So acceleration will be with a negative sign. So minus 25 centimeter per second square. Now minus 25 centimeter per second square can be written as minus 25 centimeter divided by 1 second square. Now see, we need to get it in meter per second square. So when we need to get it in meter per second square, we need not touch the denominator. We'll have to touch only the numerator and we'll have to convert only the numerator. So I would be converting this 25 centimeter to meters. Now when we convert centimeter to meter, we divide by 100. So 25 divided by 100 will give me 0.25 meters. So we get here minus 0.25 meter divided by 1 second square. So I get it as minus 0.25 meter per second square. Final velocity is 0 as I have already told you. Time is 20 seconds. I would be using V is equal to U plus AT. AT goes to the other side. We get V minus AT is equal to U. So U will be equal to V minus AT. So now what I do here is U will be equal to V is 0 minus A is taken as minus 0.25 as we have converted it here into T is 20. So minus into minus gets me plus 0.25 into 20 gives me 5 meter per second. I'll tell you how. 25 into 2 is 50 and into 10 will be 500 and then 2 places of decimal. So that means 5.00 or 5 meter per second square. So we have got the initial velocity to be 5 meter per second. 5 meter per second. Now here we need to find the displacement. So for finding the displacement, I will be using S is equal to ut plus half at square. So u happens to be 5, which we have got it here, into t is 20 seconds, it's given in the question. So in plus half into a is minus 0.25 into t square is 20 square. So we get here as 5 into 20 as 100 minus, because there's a minus sign, minus into plus gives me minus. 20 square is 400 into 0.25 divided by 2. So here what I get is 100 minus 400 into 0.25 divided by 2. So 400 into 0.25 gives me 100 divided by 2. So 100 minus 100 by 2. Now 100 by 2 is 50. So we get 100 minus 50, that is nothing but 50 meters. So distance traveled by the bus during this time is 50 meters and initial velocity of the bus is 5 meter per second. Now getting to the question number 11, exercise 2C, ICSE 9th. A body moves from rest with a uniform acceleration and travels 270 meter in 3 seconds. So the distance traveled is 270 meter, time is 3 seconds. Find the velocity of the body 10 seconds after the start. So now this is slightly tricky here. Moves from rest means initial velocity will be equal to 0. Displacement will be equal to 270 meters and time will be 3 seconds. Now we would consider only these three and we would find the value of acceleration, because acceleration is needed to find the velocity of the body 10 seconds after start. Now I would be using S is equal to ut plus half at square. Regarding which formula to use, I have explained it properly in the first video of this exercise, that is exercise 2C. The first few problems, the first video of this exercise, I have explained how to choose the equation. If you have not watched that, do watch it. So S is equal to ut plus half at square. Now I would be substituting the values. S is 270 is equal to U is 0 into T is 3 seconds. Remember we are taking only this case here. So 0 into 3 plus half into A, because we need to find the value of acceleration, into T square, that happens to be 3 square. So 3 into 3 is 9, and so we get here 0 into 3 is 0, so we get 270 is equal to 9 by 2A. So A will be equal to 2 goes to the other side, becomes 270 into 2, 9 goes other side, becomes denominator, and here I get A is equal to 270 into 2 divided by 9. So 9 threes are 27, so 9 into 30 times will give me 270. So 30 into 2 gives me 60 meter per second square. So acceleration, I have got it as 60 meter per second square. Now I would be considering the second step. That means the second part of the problem, where we need to find the velocity of the body 10 seconds after the start. Initial velocity will remain the same, that happens to be 0. Acceleration, we just got it here, 60 meter per second square. Time is 3 seconds. So V is equal to U plus AT. So that is 0 plus A into T is 60 into 10. So 60 into 10 is 600. So we get final velocity as 600 meter per second. Now coming to the 12th question, that happens to be the last question for this video. 13th question onwards, I would be doing in the next video, the link for which will be there in the description. So a body moving with a constant acceleration travels the distances 3 meter and 8 meter respectively in 1 second and 2 seconds. Calculate initial velocity, acceleration of the body. Now what I would be doing is, I would be taking two cases. For the first case, it is 3 meters in 1 second. And for the second case, it is 8 meters in 2 seconds. So taking case 1, distance will be, S will be equal to 3 meters. U will be equal to U only, because we do not know what is the initial velocity. T will be equal to 1 second plus half into A, we do not know, into T square will be 1 square, because for the first case it is 1 second. So the whole idea behind this problem is, I would be getting two simultaneous linear equations and I would be solving them to get the result. So here I just substitute S as 3, U as U, T as 1, half, A as A, and T square as 1 square. So I get 3 is equal to U plus A by 2. Now I take this as equation 1. Now I would be taking case 2, wherein again I am using S is equal to UT plus half AT square. So what I do here is, I take S as 8 is equal to U as U only, because I do not know the initial velocity, into T as 2 seconds, because for case 2 we consider the second time. So 2 seconds plus half into A is A only into 2 square. So here what I get is 8 is equal to 2u plus 2a. So as you can see here, we have considered this as equation 1 and this as equation 2. Now I would be solving these two equations. I have written the equations again here, that is 3 is equal to u plus a by 2, that was equation 1, and 8 is equal to 2u plus 2a, that is equation 2. Now what I do is I multiply equation 1 by 2. The reason is I'm trying to take out this denominator. So 3 into 2 gives me 6, 2 into u gives me 2u, a by 2 into 2 gives me a, because 2 and 2 cancels. So I get 6 is equal to 2u plus a. So from here I get a is equal to 6 minus 2u. This is equation 3. Now what I would be doing is I would be taking this value from equation 3, that is for a, and putting it in equation 2, that is in the place of a here. So I'm using the substitution method here. So substituting equation 3 in equation 2, we get 8 is equal to 2 into u plus 2 into this a is written as 6 minus 2u. Now I would just be solving it. So 8 will be equal to 2u plus 2 into 6 is 12, plus into minus gives me minus, 2 into 2 gives me 4, and u comes as it is. So 12 goes to the other side, I get 8 minus 12 is equal to plus 2u minus 4u gives me minus 2u. So 8 minus 12 is equal to minus 2u. 8 minus 12 is minus 4 is equal to minus 2u. Minus and minus cancels. I get 4 is equal to 2u, or u will be equal to 2 meter per second. So initial velocity is 2 meter per second. Now we need to find the value of acceleration also. So what I do is, since we already have an equation for acceleration, that is equation 3 here, I substitute the value of u which I have got in equation 4 to equation 3. So I write substituting u is equal to 2 in equation 3. What I get is a will be equal to 6 minus 2 into 2. So this u here is substituted as 2 here. So I get it as 6 minus 4. 6 minus 4 gives me 4 meter per second square. So the acceleration, 2 meter per second square. So 6 minus 4 gives me 2 meter per second square. So the acceleration here produced is 2 meter per second square. Hope you guys have liked the video. The next question onwards will be there in the next video, the link for which will be provided in the description. See you in the next video. Dhanyavad.